Hi there, welcome back to Green School. Today, we will be doing a walkthrough of Cambridge International AS and A-Level Paper 1 Theory Fundamentals Specimen Paper. For this walkthrough, you will need Paper 1 Theory Fundamentals Specimen Paper, question paper, as well as the mark scheme. So, you can download the question paper as well as the mark scheme just by doing a basic Google search, or you can use my link in the description below to download both the question paper as well as the mark scheme. If you use my link, you will come to this page here. And then you can just download both the question paper and the answer by just clicking on the PDF here. And if you want, you can click on this download button here. This download button will download all the 9618 paper and past year papers into your computer. And without further delay, let's look at question 1. State one difference between a kibibyte and a kilobyte. This is quite an easy question. We can just write a kibibyte is 1024 bytes while a kilobyte is 1000 bytes. Make sure you also know terms like megabyte, kibibyte and terabyte as well. Next, give the number of bytes in a megabyte form. So this is quite an easy question here. We can just use 1 times 1024 times 1024 is equal to 1048576. Definitely, let's say this is your actual exam, you can just put this one here without putting 1048576. For C, complete the following binary addition. Show your working. So this is a typical binary addition question. It's quite easy here. So first of all, we'll just put result and carry here. And then 1 plus 0 is equal to 1, and then 1 and 1 is equal to carry of 1 with 0 here, and then 1 plus 0 plus 1 is equal to 0 with carry of 1, and then 1 plus 1 and it's equal to 0 with carry of 1, and then 1 plus 1 plus 1 is equal to result of 1 with carry of 1, and then 1 plus 1 is equal to 0 with result of carry of 1 here, and then 1 plus 1 is equal to 0 with carry of 1 here, and then 1 plus 1 plus 1 is equal to 1 with a result of 1 here. Therefore, this is how we can sum these numbers here. So if you look at the answer here, we are summing two 8-bits number, but our result is a 9-bits number. Therefore, the next questions asks us to describe the error that occur when you added the binary numbers in part CI. So we can just write overflow here, since it's a typical implementation of overflow based on the example above. And then next, we can just write the answer cannot be represented in the current number of bits. So that's how you can score 2 marks for this question here. For D, complete the binary subtraction, show your working. So typically, what we will do is, we will first convert this second number to 2's complement form first, and then we will add the first number with the 2's complement form. And let's look at this. First of all, we will just reverse the bit here, resulting in this number here. And then we will just plus 1 here and result in this final value here. Then we will just add the first number with the second number here. And now let's look at the result here. So first of all, we will get 1 and 0 is equal to 1 here. And then 1 and 1 is equal to 0 with carry of 1. And then 1, 1, 1 is equal to 1 with carry of 1. And then 1 plus 1 is equal to 0 with carry of 1. And then this is just 1, we'll just go to the top here. And then 1 and 0 is equal to 1. And then 1 and 1 is equal to 0 with carry of 1. And then 1 plus 1 is equal to 0 with carry of 1 here. So definitely we can just put this one, or we can just ignore this one. It doesn't matter. Therefore, this is how you could do the binary subtraction for this question here. Yvette runs a company that books walking holidays for groups of people. She has a website that customers use to book the holidays. The website has a URL and an IPv6 address. Describe using an example the format of an IPv6 address. So first of all, we can just come up with some random IPv6 addresses. It can be any value from 0 all the way to F, since it takes in hexadecimal digits. To get the rest of 3 marks is quite easy. We can just describe the format itself. So for example, let's look at this answer here. We can just write some random values here. So if you look at this, 0, 1, 2, 3, 4, 5, 6, 7, and then C, D, E, F, and some random numbers here. And next, as I say, we can describe this address here. So we can write this one here, 8 groups of numbers. Since we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 groups of number. And then next will be, each group of numbers is 4 hexadecimal digits. And finally, to get the last mark here, we can just write each group is separated by colons. So if you look at this, all these numbers are separated by these colons here. So this is how you could get 4 marks for this question here. If you know the format of IPv6 by heart, it's actually quite doable. For B, an IP address can be static or dynamic. Describe static and dynamic IP addresses. So for this question, we just have to differentiate both static and dynamic IP addresses. For static, we can just write, when a computer disconnects and rejoins a network, the address does not change. So does not change is the keyword for static. And then for dynamic, we can just write, each time the computer rejoins a network, the address changes. So this is the main difference between static and dynamic IP addresses. For C, US company has a LAN local area network that has hybrid topology. Describe the characteristics of a LAN. As you know, we mainly use LAN in our home, school, or office building. So we can write devices connected over a small geographical area. And then we can write things like private ownership, users dedicated infrastructure, or company-owned infrastructure. Basically, just remember that LAN is for private network, and then we can elaborate accordingly. The LAN has a range of different topologies. One subnetwork connects 4 computers and one server set up as a star topology. Describe how packets are transmitted between 2 of the computers in this subnetwork. Basically, I have drawn the star topology here based on the question here. Let's assume that we will be using this laptop as a sender, then we have the server here, and then we have this PC here as the recipient. So first of all, we can just write something like this. We can write packet has address of recipient. It means that when the sender sends a packet, it will contain the address of this recipient here. And then we can write sender transmits packets directly to the server based on this diagram here. And next will be server reads address and identifies where recipient is. So this server here, he has to read, hey, where is my recipient? He will try to find my recipient here. And finally, we can just write this one here. Server transmits packets directly to the recipient. So for this type of question, sometimes you can spend some time to do some drawing and visualization, and it's going to be way easier for you to answer the question. For D, the LAN has both wire and wireless connections. Ethernet cables connect the computers to the server, identify 3 other hardware components that might be used to set up the LAN. This is also quite a doable question if you know all the hardware of LAN by heart. Let's look at the picture I draw on the right here. Starting from the bottom, we have the computer with a network interface card connected to the server using Ethernet cable, and then server to router, router to modem, and then modem to the internet through copper or fiber optic cable. Then we can just select any of the items here and put it as an answer here. So for example, the first answer we can just put network interface card based on the diagram here. And next will be just router, and finally will be just modem here. Now let's look at the last question of question 2. Describe how carrier sends multiple access collision detection, CSMA/CD manages collisions during data transmission. So this is quite a common question that get asked in the past exam. So make sure you know how to answer this particular question. We can write, collision happens when 2 devices transmit at the same time. And then if a collision occurs, each workstation waits a random time before retransmitting. Therefore, this is how you could score 3 marks for this question here. For those of you who are doing my fast track program, for every question, I have listed down the chapter as well as the video name that you could revise from. For example, for this question here, you can just refer to the video on Internet and CSMA/CD from chapter 2 here to do your revision. And now let's proceed to question 3. Question 3 is a typical database question, so let's dive deep into this question here. Murdoch has a holiday company database that includes data about holidays such as the location, date, duration in days, data about the customers and the holidays they have booked. Murdoch has normalized the database which has 3 tables. Draw an entity relationship ER diagram for the normalized tables. So the keyword for this question here will be holidays, customers and book here. Based on the keywords here, we roughly know that we need a table for holidays, customers, as well as one for booking. Therefore, the first table will be customer here, and then we have holiday here, and finally we have booking here. The next thing that we have to do is identify the relationship between them. So let's start with customer and booking here. So we can just ask ourselves here, can a customer has many bookings? The answer is yes, so it's a one-to-many relationship. Therefore, we can just draw like that here. And next will be between holiday and booking here. Same thing. Does one holiday plan can appear in many bookings? The answer is yes again. So it's a one-to-many relationships also. Therefore, we can just draw one-to-many relationships here. Finally, do we have any connection between customer and holiday here? The answer should be no, since customer table will contain customer data, whereas holiday table will contain data about holiday plan. So this is how you can construct the ER diagram. If you follow my steps here, it's actually quite easy to do. And then the next question is complete the table to identify the primary key and foreign key for each of the tables you identify in part AI. If the table has no foreign key, write none. So let's start with this customer table here. And what would be the primary key for customer table? It will be just customer ID. And does it have any foreign key? Foreign key will be none, since it only has a one-to-many relationship here to the booking table here. And the next will be holiday table here. And what's the primary key? It will be just the holiday ID here. Does it have any foreign key? Same thing, it will be none again. And finally will be the booking table here. What is the primary key for booking table? It will be booking ID here. And for foreign key, we can see that for this booking table here, customer has a one-to-many here, and then holiday has a one-to-many here. Therefore, the foreign key will be this one here, both customer ID and holiday ID here. So this is how you could fill in the table based on the ER diagram here. And now let's look at the next question. Explain why the holiday database is in third normal form 3 and F. So on the right here, I have put both the ER diagram as well as the primary key and foreign key tables here to help us to answer this question here. So first of all, based on the ER diagram here, we can see that it has no many-to-many relationships. And the next point will be this one here. All fields in each table are fully dependent on the primary key for each table, which is also one of the criteria for normalization. For B, the holiday companies has several members of staff. The database has two additional tables to store data about the staff. So we have the staff table here and the schedule table here. The following table shows some sample data from the table schedule here. So we have some sample data here. And now let's look at the question here. Write an SQL script to display the first name and the second name of all staff members working on 22/5/2020 here. From this question itself, we know that we need data from both staff and schedule table, so it's going to be an inner join question. So first of all, we'll just do select staff.first name, staff.second name from staff. So for this kind of question, we should always put the table name and then dot and then the column name here. And next, we'll be doing the inner join here. So inner join schedule table here on staff.staffid is equal to schedule.staffid. And finally, we will add the where clause based on the question requirement, which is where schedule.workday is equal to 22/05/2020 and then semicolon here. Always make sure that you end the statement with a semicolon as well. And now let's look at the next question. Write an SQL script to count the number of people working on the morning of 26/05/2020. This question only requires data from one table, which is the schedule table. So we can just write select count bracket staff ID from schedule here. And then we will just add in the where condition here. So where workday is equal to 26/05/2020 and morning is equal to true here, since we only want people who is working in the morning shift. And finally, remember to end the statement with a semicolon here. A cake factory uses machines to make cakes. Complete the following descriptions of types of system. Write the correct missing term in the spaces. So based on this question itself, we know that this question is about the monitoring and control system. So we can just fill in all the keywords related to this topic itself. So first of all, the factory uses a blank system to record data such as the number of cakes being produced each hour. So for this blank here is definitely the monitoring system here. And next, when the data collected from sensors are analyzed and used as blank, it is a blank system. So for this question here, this will be a feedback here, and then this is a control system. And finally, one example of this system used in the factory is to maintain a consistent temperature in the ovens. It uses a blank to measure the value. So for this blank here, we can just put temperature sensor here. Therefore, this is how you can fill in the blanks for this question here. As I say, if you know all the keywords for monitoring system and control system, this is quite a doable question. Cake mixture is mixed in a large pot. A conveyor belt moves the cake tins beneath the pot. The conveyor belt stops and a set quantity of the cake mixture fills the cake tin. The conveyor belt then moves and another cake tin is positioned beneath the pot. And the question is, explain how the control system will ensure the correct amount of mixture is placed in the cake tins. This is a 5 marks question, and this is a slightly more complicated question. Before deriving the solution, let's look at what we need first in order to help you to tackle this question here. For this type of question, you should always spend some time to visualize the end-to-end workflow first before coming out with the final solution. First, we mainly need 2 sensors here. One is to detect when the cake tin is below the pot here. And the second sensor is used to detect when the cake tin here is getting full here. So that we know that we have to move on to the next tin. And then we need a microprocessor. This is mainly used to control and handle all the operations. Finally, we need 2 actuators here. One is to start the pot to fill in the cake mixture, and the other one is to stop or start the conveyor belt. This is so that the cake tin will be right below the pot for filling. And once we know the rough process and the devices needed for this operation, we can just write the answer in our own wording here. Remember, the key idea is you have to understand the whole workflow first so that you can describe it accordingly. So first of all, we can just write when the pressure sensor detects the tin is in the correct place, and then a message is sent to microprocessor, which sends a signal to an actuator to stop the conveyor belt and sends a signal to another actuator to release the cake mixture. And then a pressure sensor continuously records the weight of the cake mixture in the tin and sends a reading to the microprocessor. And finally, when the microprocessor detects that the reading matches the desired weight, it sends a signal to the actuator to stop releasing the mixture and sends a signal to another actuator to move the conveyor belt. Therefore, this is how you could score 5 marks for this question here. As long as you are able to roughly describe each step, you should be able to get at least 4 or even 5 marks for this question here. For C, the cake factory has servers that store its confidential recipes and control the factory machines. Describe the implications of a hacker gaining access to the cake factory's servers here. So this is pretty easy here. We can just write things like can access private or confidential data. And once this hacker access all this data, he can then sell the recipe to competitors. At the same time, the hacker can access the commands for the machine. And finally, the hacker can stop the machines working, and it will cause the company to lose money due to hog in production. So this is how you could score 4 marks here. As long as you have 4 main points, you should be able to score full marks here. And then now let's look at the next question here. So explain how the company could protect its data against hackers here. So this is pretty simple here. First of all, you can just write install and run firewall, and then make sure the firewall is updated so that it can block signals that do not meet requirements. And next will be strong password in the system. So this is a typical answer for this kind of question. And finally, we can write requires additional authentication. So for example, it needs to verify your login through email, SMS, or facial recognition. If you are enjoying the walkthrough so far, definitely give this video a thumbs up to help with the YouTube algorithm to help more students like you. If you are preparing for the 9618 Paper 1 exam and looking for an efficient way to master all the required topics in the shortest possible amount of time, definitely check out my AS Fast Track program. In this program, I will guide you everything that you need to know for the AS paper, whether it is theory-based topics, practical-related questions from paper 1, or even tricky Sudoku questions from paper 2. I break down all the topics from chapter 1 to chapter 12 into bite-sized videos so that you can learn all the topics within a short amount of time. This is very important as you want to make sure that you spend your limited time on the right resources to get the best possible grade for your upcoming exam. To be honest with you, I have so many students who didn't get good grade before joining my program as they were spending their time on the wrong resources or getting guidance from the wrong person. So if you are interested, just click on the description or the comment section below on what you can do next. And now let's look at the next question. For D, the machines have a counter to record the numbers of cake tins filled. Each time a cake tin is filled, the counter is increased by 1. The value is stored in an 8-bit register and the current value is shown. Show the value of the binary number after another 5 cake tins have been filled. So this is just a basic math question here, and let's convert the above number here into denary first. So the denary form will be this 9 here, since we have 8 plus 1 here. And then what is 9 plus 5 is equal to 14 here. And how do you get 14? It's pretty simple here. Basically just 8 plus 4 and then plus 2 here. And the rest of the boxes you can just fill in by 0 here. The following table shows some assembly language instructions for a processor which has one general purpose register, the accumulator ACC. At the end of each day, the register is reset to 0. Write the assembly language statement to reset the register to 0 here. So what this question wants us to do is making the end result to 0 all the time. So it's quite easy. We can just use an AND gate here. For example, let's do some revision about AND gate here. If you look at AND gate here, as long as the input has 0 here, so 0, 0 or 0 here, the output will always equal to 0 here. Therefore, the answer is equal to AND hash 0 here. So make sure you remember the hash here. A 2-place logical shift to the left is performed on the binary number shown in part D. Show the result of this logical shift. So from part D, we have this binary number here. And then we'll move it 2 places to the left, meaning that I will remove this to 0 here. And then we will start from this 0 here. So I will start filling in the boxes from this number here. So 0, 0, 1, 0, 0, 1. And the remaining 2 boxes here, I will just fill in 0 here. And then state the mathematical result of a 1-place logical shift to the right on a binary number here. So this question is basically asking what happens when you shift the bits by 1 to the right. Let's take the result from the above equation here and do some shifting here. So for example, based on the result here, the resulting number will be 36 here because 32 plus 4 is equal to 36 here. And for example, if we shift everything to the right by 1 place, we will get 18 here. Why 18? Because 16 plus 2 is 18 here. So the final answer will be division by 2 because 36 become 18 here. For E, the factory servers run software that makes use of artificial intelligence. Explain how the use of AI can help improve the safety and efficiency of the factory. So first of all, we can write machines can learn from past problems or mistakes. So this is the typical usage of AI here. And next, they can adapt to stop the same problem from occurring again. So this is like a preventive action. Finally, they can learn to predict what might happen and raise an appropriate alert here. So this is like a predictive action. In general, we use AI to do both preventive and predictive action, so always bear this in mind and you can always write the sentences accordingly. Draw a logic circuit diagram for the logic expression X is equal to not A or B or C, or B and C and D. Normally, I will convert this into equation form here. Of course, this is not necessary, but looking at this equation, it's easier for me to draw the logic circuit itself. Take note that for this syllable itself, we can assume that each logic gate can only take in 2 inputs. So for example, A plus B plus C here, we don't do like 3 inputs into an OR gate, so we have to split them into stages here. And now, let's start drawing the equation from the left all the way to the right here. First of all, I will just draw A or B here. So A going to this OR gate here, B going to this OR gate here. And then we have to combine with C here. So C go into another OR gate here, and then the output from A and B will go into this OR OR gate here. So we are done with A plus B plus C. And then we have to NOT the result here. So NOT gate here. And then we are done with the first equation here. And next we'll do this B dot C dot D. So first of all, we have this C and D at the bottom. So let's do C and D first. So C and D going to this AND gate here, and then B has to go into another AND gate here. So B comes into this AND gate here, and then the result from C and D goes into another AND gate here. So we are done with this B dot C dot D, and then we have a plus here, meaning that we have to have one more OR gate here. And the input for this OR gate will be this one here, coming from A plus B plus C, not here, and then finally B dot C dot D from this one here. So this goes into this OR gate here. And lastly, not to forget that we have to match the output from this OR gate into X here. So that is how we can construct the logic circuit here. It looks a bit complicated at first, but once you know the trick, it's actually not that difficult. And now let's look at the last question for this paper here. Complete the truth table for the logic expression. X is equal to A or B or not A or B or C. So for this question here, we are supposed to fill in the output for this X here based on this equation here. So first of all, I will just convert this form into an equation form as usual. And then from this equation form, I will draw the logic circuit here. So this is the logic circuit representation based on this equation here. And then in between, I will have to label the intermediate state here. So for example, I have D here, and then I have E here, and then F here, and then G here, and finally we have this X here. So all these intermediate states are used to represent the output from all these gates here. After labeling all these intermediate states, I can just create a new column using the working space above. So for example, column D, column E, column F, and column G. And then we will use this table to get output X here. And now let's do the first row together. For example, for D here, we have A and then B going to this SOR gate here. So the result will be 0 here. Since 0, 0, we get 0. And then for E, it will be based on B and C here. So 0, 0, we get 0 here. And then for F, it will be based on E and then based on A here. So what is A? A is 0 and E is also 0 here. So 0, 0, we get 0 here. And then G is the NOT gate of this F here. So it will be 1 here. And 1 is for X. X is based on D and then G here. So what is D? D is 0 and then G is 1. So 0, 1, you get 1 here. Then we can repeat the same procedure for the other row here. So for example, second row, third row, fourth row, fifth row, sixth row, seventh row, 8th row here. Definitely feel free to pause this video now and see if you are able to produce the same result as me here. And lastly, if you enjoyed this walkthrough or have learned something new from this video, please like, subscribe and hit the bell icon to get notified of new content. At the same time, as mentioned before, if you want to master your 9618 Paper 1 or Paper 2 exam in the shortest possible amount of time, you can check out my AS Fast Track program. The link is in the description or the comment section below. Thank you, and I'll see you again then. Bye bye.